Hello everyone. The headline of this tutorial is Curve Sketching, Lesson 4.4. Exercises 1 to 4 match the graph of the function with that of its derivative. The first graph, we have a linear function with negative slope, and the derivative of this, the graph of the derivative of this function is a horizontal line parallel with x-axis. Under x-axis it is choice D. Therefore, the graph of the derivative of this function is D. Question number 2. As you see, we have the graph of trigonometric function. The function is decreasing from 0 to pi over 2, and if we see this graph, the function is under x-axis from 0 to pi over 2, and the function here is increasing from pi over 2 to pi, and the function here, the graph here, is over x-axis from pi over 2 over pi. Therefore, this graph is the derivative of this function. Also, as you see, the domain of this function is R, but the domain of this function is from negative infinity to 2. The domain of this function is R except 0. Therefore, the graph of this function is, the derivative of this function is A. Number 3, the domain of this function is all real number except 0, and we have here the domain all real number except 0, but the domain of this function is from negative infinity to 2. Therefore, this graph is not derivative of this function, but B is the graph of the derivative of this function. Question number 4. The domain of this function is from negative infinity to 2. Also, the domain of this function is from negative infinity to 2, and the function is increasing from negative infinity to 1. Here, the function is over x-axis from negative infinity to 1, and the function is decreasing from 1 to 2, and here the function is under x-axis from 1 to 2. Therefore, the graph of the derivative of number 4 is C. Question number 5. This is the graph of the function f of x. We have 4 needed. Needed A, for which value of x is f prime of x 0, positive, and negative. F prime of x is equal to 0 when the function has a horizontal tangent line. At negative 2, the function has horizontal tangent line, and at 2, the function also has horizontal tangent line. Therefore, f prime of x equals 0 when x equals negative positive 2. For which value of x the derivative of the function is positive? The derivative of the function is positive when f of x is increasing, and the function is increasing from negative infinity to negative 2. Therefore, negative infinity to negative 2, open interval, union, also the function is increasing from 2 to positive infinity, 2 to positive infinity. This is the intervals of where the derivative of the function is positive. For which value of x is f prime of x is negative? F prime of x is negative when the function is decreasing. And here, as you see, the function is decreasing from negative 2 up to 2. Therefore, from negative 2 to 2, the function is negative. The derivative of the function is negative. Needed B, for which value of x f double prime of x is 0? If double prime of x is equal to 0 when the function has an inflection point, and as you see, the function change from convex to concave at 0. Therefore, f double prime of x equals 0 when x equals 0. For which value of x is f double prime positive? F double prime is positive when the function is concave, and the function is concave in the interval 0 to positive infinity. 0 to positive infinity, the function is, the derivative of the function is positive. The second derivative of the function is positive. For which value of x is f double prime of x is negative? F double prime of x is negative when the function is convex, and the function is convex in the interval negative infinity to 0. Negative infinity to 0. In this interval, the double prime of x is negative. Need to see on which interval is f prime of x an increasing function. F prime of x is an increasing function when the function is concave, and the function is concave from 0 to infinity, 0 to positive infinity. And f prime of x is decreasing function when the function, the graph of the function is convex. Therefore, the function is decreasing from negative infinity to 0. For which value of x is f prime of x minimum? F prime of x is minimum at 0, at x equals 0. Since 0 is an inflection point for this function and the function changed from negative to positive. Therefore, from negative to positive, we have a local minimum value for f prime of x. Question number 6 to 17, sketch the graph of the function f of x, number 6, f of x equal x power 2 over x power 2 plus 3. To sketch the graph of any function, we need to find some important properties for the function. First, we need to find the domain of the function. We need to find the x-y intercept of the function. We need to find the symmetric of the function. We need to find vertical, horizontal, slant asymptote, increasing, decreasing function, local and local minimum and maximum extrema, and inflection point and interval of concavity of this function. Let us find it one by one. The domain of this function, to find the domain, set the denominator equal 0 and find the value of x. X power 2 equal negative 3, then x power 2 equal, x equal negative positive square root negative 3, not a real number. Then therefore there is no value make the denominator 0, and the domain of f equal to r, or real number. For x-intercept, set y equals 0 and find the value of x. If we set f of x equals 0, then x power 2 over x power 2 plus 3 equals 0, cross multiplication, then x power 2 equals 0, then x equals 0 is x-intercept value for this function, 0, 0. For y-intercept, set x equals 0 and find the value of y. Therefore, y equal to 0 over 0 plus 3 equal to 0 over 3 equal to 0. Therefore, 0, 0 is also y-intercept for this function. For the symmetry, f of x equal even function over even function plus even function. Even plus even over even, therefore the function is even. For vertical asymptote, set the denominator equals 0 and find the value of x. X power 2 equal negative 3, therefore x equal negative positive square root negative 3, not a real number. There is no vertical asymptote. For horizontal asymptote, find the limit when x approaches to negative or positive infinity for the function x power 2 over x power 2 plus 3. Since the numerator and denominator has the same degree, therefore the answer is the coefficient of the leading term in the numerator 1 over the coefficient of the leading term in the denominator 1 equal 1. Therefore y equal 1 is horizontal asymptote for this function. For the slant asymptote, the numerator should be one more, the degree of the numerator should be one more than the degree of the denominator, but here the degree of the numerator and denominator are equal, so there is no slant asymptote. Find the interval of increasing and decreasing of this function f prime of x equal to the denominator x power 2 plus 3 times the derivative of the numerator 2x minus the numerator x power 2 times the derivative of the denominator 2x over denominator square. Simplify this derivative. 2x times x power 2, 2x power 3, 2x times 3, 6x minus 2x times x power 2, 2x power 3 over x power 2 plus 3 square. Set it equals 0 to find the critical point. Remove 2x power 3 with negative 2x power 3. Then 6x equals 0. X equals 0 is a critical point for this function. Find the interval of increasing and decreasing of this function. This is the critical value. And this is the sign of the first derivative. Also, if we set the denominator equal 0 to find the value, make the derivative 0, we see that x power 2 plus 3 equals 0, then x power 2 equal negative 3, then x equal negative positive square root negative 3, not a real number. There is no value, make the first derivative 0. Therefore, the only critical point is 0. To find the sign of the derivative before 0, take negative 1, substitute it in the derivative of the function. 6 times negative 1, negative 6 over positive number, negative. If we take the value greater than 0, take 1. 6 times 1, 6 over any positive number is positive number. Therefore, the function is decreasing from negative infinity to 0. The function is decreasing, and the function is increasing from 0 to positive infinity. The function is increasing, and 0, 0 is local minimum value for this function, and 0, 0 is local minimum value for this function. To find the inflection point and the interval of concavity, find the second derivative of this function. F prime of x equal to 6x over x power 2 plus 3 square. Then if double prime of x equal to the denominator x power 2 plus 3 square times the derivative of the numerator 6 minus the numerator 6x times the derivative of the denominator 2 x power 2 plus 3 times 2x over x power 2 plus 3 square power 2 means power 4. Simplify the second derivative of this function f double prime of x equal to 6 times x power 2 plus 3 square minus 2x times 6x 12 x power 2 times 2 24 x power 2 times x power 2 plus 3 over x power 2 plus 3 power 4. Factorized by x power 2 plus 3 for the numerator, then x power 2 plus 3, 6 times x power 2 plus 3 minus 24x power 2 over x power 2 plus 3 power 4. Reduce x power 2 plus 3 with x power 2 plus 3 power 4 equal to 6x power 2, open the bracket, plus 18 minus 24x power 2 over x power 2 plus 3 power 3 equal to 6x power 2 minus 24, 18 minus 18x power 2 over x power 2 plus 3 power 3. Set it equals 0, cross multiplication, then 18 minus 18 x power 2 equals 0, factorized by 18, 1 minus x power 2 equals 0, then x power 2 equal 1, then x equal negative positive 1. Find the interval of concavity of this function. Find the sign of the double prime before and after the critical point, negative 1, 1. Before negative 1, take negative 2. Here, the denominator is always positive. If we set negative 2, then negative 2 square for 4 times 18, negative value 18 minus 18 times 4 is negative value. Between negative 1 and 1 take 0, 18 minus 0, 18, positive value. When x greater than 1, also the function is negative since 18 times 4, it's greater than 18, therefore is negative. Then the function is convex from negative infinity to negative 1, union 1 to positive infinity, and the function is concave in the interval negative 1 to 1. Here the function is concave, and here in this two interval the function is convex. And negative 1, f of negative 1 and 1 f of 1 are two inflection point for this function. The graph of this function will be this is the horizontal asymptote at y equal 1, and here the function at 1, negative 1 has an inflection point. Therefore, the function will be the inflection point, and also at -1 we have an inflection point, one, 4. This is the graph of this function. Question number 7, sketch the graph of the function f of x equal x power 2 plus 1 over x power 2 minus 9. Find the domain of this function, set the denominator equals 0, and find the value makes the denominator 0. X power 2 equal 9, then x equal to negative positive 3. Therefore, the domain of this function equal to all real number except -3 and 3. For x-intercept, set y equals 0, x-intercept, then y equals 0, and the function will be x power 2 plus 1 over x power 2 minus 9 equals 0, cross multiplication, then x power 2 plus 1 equals 0. That means x power 2 equal -1. It means x equal negative positive square root -1, not a real number. There is no x-intercept value. For y-intercept, we set x equals 0 and find y. 0 plus 1, 1, over 0 minus 9, -9. Then -1 over 9 is y-intercept value for this function. The point 0, -1 over 9 is y-intercept value for this function. For symmetric, the function is even plus even over even minus even equal to even plus even, even over even minus even, even over even, even. Therefore, the function is symmetric with y-axis. For vertical asymptote, we set the denominator 0. We solve it here. The function has two vertical asymptote, x equal negative positive 3. For horizontal asymptote, we find the limit when x approaches to negative positive infinity for the function x power 2 plus 1 over x power 2 minus 9 equal to, since the numerator and denominator are the equal degree, therefore the coefficient of the numerator of x power 2 is 1 over the coefficient of the denominator is also 1. Y equal 1, sorry. Therefore, y equal 1 is horizontal asymptote for this function. For a slant asymptote, since the numerator and denominator have the same degree, there is no slant asymptote. No slant asymptote. Now, find the interval of increasing, decreasing, and the local minimum extremum for this function. F prime of x equal to the denominator x power 2 minus 9 times the derivative of the numerator 2x minus the numerator x power 2 plus 1 times the derivative of the denominator 2x over denominator square. Simplify this derivative, 2x times x power 2 minus 9, open this bracket, 2x times x power 2, 2x power 3, 2x minus 9 minus 18x minus 2x times x power 2, 2x power 3, 2x times 1, 2x. over x power 2 minus 9 all square equal to 2x power 3 minus 2x power 3, negative 18x minus 2x, negative 20x over x power 2 minus 9 all power 2. Set it equals 0. Cross multiplication, then negative 20x equals 0. It is mean x equals 0 is the critical point for this function. Find the interval of increasing and decreasing. This is the critical point f prime. We have 2 point. 2 value makes the denominator of the derivative 0, since x power 2 minus 9 equals 0. All power 2 equals 0, then it is mean that x equals negative positive 3. This is negative 3 and this is positive 3. Find the sign of the derivative before and after this value. When x equals negative 4, since the denominator is always positive, negative times negative positive, the function here is positive. Between negative 3 and 0, take negative 1. Negative 1 times negative 20, also positive. Between 0 and 3, take 1. The function is negative. And when x greater than 3, 4 times negative 20, negative value. Therefore, the function here, the function in this intervals are increasing and in this interval are decreasing. From negative infinity to negative 3, union negative 3 to 0, the function is increasing. And from 0 to positive 3, union 3 to positive infinity, the function is decreasing. And the point 0, f of 0, 1 of negative 1 over 9 is local maximum value for this function. Find the double derivative of this, the second derivative of this function to find the intervals of concavity equal to the denominator x power 2 minus 9 square times the derivative of the numerator negative 20 minus the numerator negative 20x times the derivative of the denominator 2 times x power 2 minus 9 times 2x over x power 2 minus 9 square power 2 means power 4 equal to negative factorized by x power 2 minus 9 for the two terms in the numerator. From the first term, we have negative 20 times x power 2 minus 9 minus times minus plus 20x times 4, 80 x power 2 over x power 2 minus 9 power 4. Since 2 times 2, 4, 4 times 20, 80 x power 2 equal to reduce x power 2 minus 9 with x power 2 minus 9 power 4. Open this bracket, negative 20 x power 2 plus 180 plus 80 x power 2 over x power 2 minus 9 power 3 equal to negative 20x power 2 plus 80, 60 x power 2 over x power 2 minus 9 power 3. Set it equals 0, cross multiplication, then 180 plus 60 x power 2 equals 0. It is mean that 60 x power 2 equal negative 180. It is mean that x power 2 equal to negative 180 over 60 equal to negative 3, then x equal to negative positive square root negative 3, not a real number. There is no inflection point for this function. Find the concavity intervals of this function by finding the sign of the double derivative of this function before and after the value makes the denominator 0, negative 3 and 3. But since negative 3 and 3 are not within the domain of this function, so negative 3 and 3 are not inflection points. As you see, when the x is less than negative 3, negative 4 square is greater than 9, therefore the denominator is positive, and the numerator is also positive, since positive plus positive is positive, therefore the function is positive, and the second derivative is positive, and the function is concave in this interval. Between negative 3 and 3, take 0, 0 minus 9, negative 9, negative 9 power 3 is negative value, positive over negative value is negative, therefore the function here is convex. When x greater than 3, take 4, 4 power 2, 16, 16 minus 9 is positive, positive over positive, the function is positive, the second derivative is positive, and the function is concave. Therefore, from negative infinity to negative 3, open interval, union 3 to positive infinity, the function is concave, and from negative 3 to 3, open interval, the function is convex, and the function has no inflection point. The graph of this function will be, we have a horizontal asymptote at 1, vertical asymptote at 3 and negative 3. 0 is local maximum value for this function, and the interval of decreasing is from 3 to positive infinity, and the interval of increasing from negative infinity to negative 3, from negative 3 to 0, and the interval of decreasing is from 0 to 3 union 3 to positive infinity. The point 0, negative 1 over 9 is local maximum value, and the function is concave from negative infinity to negative 3, 3 to positive infinity, convex from negative 3 to 3. See you next lesson.